me know when you got everything open.
Okay, I got my preparation assignment out. I am opening the quiz.
Opening the quiz?
Yeah.
Okay.
Have you been thinking about a project to do?
I read that yesterday. It gives some. Have you read the link to it?
I just watched his video
Okay.
of what he said to do.
Yeah.
So no, I haven't read. But I was reading what all he, wanted in the design the study paperwork.
Yeah. Yeah, because there's a link to it, kind of gives a little explanation of what to do and some possible topics. So.
Yeah. And he said he'd rather. He said it's fine to if we're gonna count Skittles or M&Ms or something like that, but he likes something different than. He said 80% of the class will do something like that.
Yeah.
Let's see. So, yeah, we just need to figure out.
Yeah, we could.
Something that'll be, easy for us. He said, don't make anything too complicating. I need to figure out how many people are we, if we're going to do people, dealing with people, how many people would we need to observe, or how many cases are we going to need to gather, whether we're collecting prices on something or.
Yeah. I don't think it's that much. So.
I mean, because to have a normally distributed thing, you have to have 30.
Yeah.
And if you do different groups, does that mean, if you're comparing groups, say men versus women, or do you have to do 30 of each group? Or does all the groups together equal 30?
I think it's each group would be 30 or more, wouldn't it?
Yeah, that's what I was thinking.
Yeah.
Okay. So anyways, let's do the readings or the assignment. Lesson 17. Did you want to go over part 1?
I don't think so, because it's all the formulas.
Okay.
Unless you had a question on it, but.
No. But I didn't figure out what I didn't ever remember reading about the P-hat. P-hat, whatever it's called.
Oh, the P-hat? Yeah.
Yeah, but I guess it's just your P. Well, it just dawned on me. X bar. P, that little thing on the
P-hat, the little thing would be the. Oh, okay.
Okay, that just dawned on me.
Well, there we go.
Makes sense, but I'm like, what is P-hat? Okay.
Yeah. All right, so let's do part 2. Number 1 says confidence interval. In an October 2008 poll, 684 of 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. Find the proportion of those surveyed who have been in an automobile accident in the last 5 years. So we would just do.
I'm sharpening my pencil here.
Okay.
All right. So find the proportion of those surveyed who had been in accidents in the last 5 years. So
we would just do 684 divided by 1006.
yeah. I grab my phone. Okay, and then to check that, what did you get for your answer?
I got 0.679.
Okay. So to check that, you have to go the sample size times that number. It has to be greater than 10, which it will be 1,000
Yeah.
times that. So, or 1 minus 0.6 would be like a 0.4, 0.3 or something, and times that by 1,000. That will still be more than 10.
Yeah.
If you want to, I guess you could really actually do it. But
Yeah, but yeah, obviously it's going to be more than 10.
so is that the only requirement?
Yeah, it's just that whether it's like you said, n times p hat has to be greater than 10, or n times 1 minus p hat has to be greater than 10. So
Let's see, but actually, is it?
we'll check if.
Well, because it says it's just p. It doesn't say p hat in the formula. But is p hat this?
No, it is the p hat, is it?
In the
Because it would
formula?
be the 6. Yeah, it'd be 680. It'd be the 684 divided by 1006. Which
Was it
equals.
in the homework? Wasn't it saying that p hat and p? Does it say they were the same? I don't remember.
Yeah. So yeah, you just do 1,006 times 0.679. 683 basically. So yeah, they're well over 10.
All right. So the margin of error. Get that formula.
Margin of error. Formula.
So it's M equals business score, which 95, 96. So yeah, 1.96 times the square root of
And it's divided by the 1006, right?
yeah.
Have you got your answer yet?
Um,
I'm still working on mine.
crap. Yeah, I just have to times it by the z-score now.
No. Okay, I got 0.028.
What did you get?
0.028?
Okay. Or 0.029.
Yeah.
Ending
Yeah.
up. Okay. So now you add, to do the confidence interval, you would add that to something.
Are you saying for C?
Well, no. I just saying for like the margin of error, you always figured out the margin of error and then added it to the mean or whatever, and that's how we got the confidence interval. Well, that's for D. It says construct. You have to figure out how to do the confidence interval. Because remember, for the last lesson, you could add or subtract that confidence interval. Or I mean, the margin of error.
Yeah.
So, from the p-hat. No. Yes. You subtract it for the...
So you subtract and add 0.029 to 0.679?
Yes. So that's your p-hat is the 0.679.
Yeah. Okay. So I got 0.651 and 0.708.
You went 0.679 minus 0.029, and you got 0.651.
Yeah.
I just got a 0.65. Oops. Point 0.651. Huh. Were you using the whole number?
Now I just did 0.679 minus 0.029.
Oh, that's weird.
Yeah.
I just get a. Okay. Maybe next time I'll do. I don't know. That's weird.
Yeah, that is weird.
Because you're not supposed to round. They said you're not supposed to round any numbers. That's like just when you're doing the whole, like say the margin of error formula. But
Yeah.
then once you get it, you can round it.
Mm-hmm.
Well, no, that's weird. So how many college students should you survey if you want 95% confidence interval for margin of error no more than 0.015? So the sample size calculation where n equals something.
N equals 1.96 divided by 2.
I'm actually still just writing out my formula to see what I have to do.
Okay.
Plugging it all in.
Okay, I got.
Okay.
Got 4,268.
You got your answer?
Yeah.
I had to run get my phone charger.
Okay.
Sorry.
Okay.
Not on top of things this morning. Okay. My computer was dying. My phone was dying. I have to plug it all in. Okay. So 1 minus 9. Times Almost done here.
Okay.
Holy cow. Is that right? Just a minute. Oh, Liam, no. No. Okay, do you have all your little answers saved? 1 minus, because when I went 1.96 divided by 0.015, I got 130.66, and then I squared that, and it was like 17,000.
For this letter E?
Yeah, I'm solving for n, getting the sample size.
Which formula are you using?
I used the n equals z divided by m, and then you square that,
Mm-hmm.
and times it by p, and then
it's
1 minus p. Am I doing it wrong?
It's because you have to use n equals z divided by 2m squared, because it didn't give us
real p.
Yeah, it didn't give you the p basically. So.
Okay. Well, because all
it
I'm
gives
so
you.
confused because I was thinking that somewhere I'm reading, I thought I remembered my memory that p hat was equal to p, but it wouldn't. I don't know what I read.
Yeah, it is. It's p is equal to p hat, but in letter E, all it gives you is the 95% confidence interval and the margin of error. It doesn't give you a prior estimate for P.
But we're going off of this whole, it's all combined with, it's all under question 1.
Mm-hmm.
So we have that information. We have the p hat. It's 0.679.
Yeah. I don't know, because I read that as well.
I mean, because we have that value already. So we're not just going by strictly the information in E. We've got all this other information. Let me finish. Was your answer right compared to the thing?
Mm-hmm. Gosh. Yeah.
Okay. I'm just trying not to get confused, because where they said P is the same as P hat, and it says if in these equations that if you have that information, then you can use that equation I was using.
Yeah.
Okay. So what was your answer?
4,268.
Okay. Now other way I got 3,741. Okay. So, did you plug that in the applet already? Or wait,
No,
that's
you don't have
did you
to.
plug it for the hypothesis test? Oh, we're doing something different now. Okay.
Yeah.
It's a totally different question. Okay. Now you're interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above. Okay, so we are using it. So 60% would be our P. Would be our true P.
Yeah.
So the null, if it's over, so the null would be
Would be
like
P.
is it P? P is equal to
0.60.
Or P is greater. Let's see. Yeah, greater than 0.60.
Greater, now you're interested in testing.
Okay, so now I gotta do the z-score for that. So you take your P, which is 0.679 minus 0.60 divided by that big formula. Let's see. Okay. I don't know if this is right, but it just doesn't look right. Let me compare it. That's not right. Let's see.
Oh, what did you get?
Well, I got a 331 point something. Trying to see what I did wrong. Okay. So for my equation, I went 0.679 minus 0.60, which gave me a 0.079 for my top number.
Mm-hmm.
Did you get that?
Yeah.
Okay, and then I went 1 minus 0.06, which was 0.4. And that's where I messed up, I think. No. So I got a 24 for that top number for the next half. A point, 0.24. Did you get that? Divided by the sample size.
I'm doing it again as well because I missed. I'm on the dividing the 0.60 times 1 minus all that divided by 1006.
Okay, well, tell me what you got when you did the 0.60 times the 1 minus 0.60. What number you got for that one?
Oh, 0.24.
Okay. So, and then when you do that, you should get like a 0.00. When you go 0.24 divided by the sample size, you should get like a really small.
Yeah.
8, 5, 6. Okay, and then you're supposed to take your 0.079, divide it by that number. Wait a minute. I didn't do the square root. That's what I did. I didn't do the square root of that teeny tiny number. Okay. Okay, so you should have that square root was 0.015445661.
Yeah.
Okay. I didn't get it right.
What did you get?
I got 5.115.
Yeah, that's what I got.
And their answer's 5.173.
Mm-hmm. Wrong,
Well,
or
okay, the only thing we could have gotten wrong is the p hat, but our p hat I think was the same as theirs. Yeah, ours is. Well, they had 0.6799.
yeah, that's probably.
So maybe that was the deal. Why it's different. I think I've got my applet open. I was gonna plug it in and see if that with putting in our number, if the probability or whatever is different.
Yeah.
Pero como antes me hubieras hablado para decirle, como ella ya tuvo de estos, dice que no le gustó nada, solo tuvo que vender.
So I have it's going to be really, really, really small.
No quería algún líquido
Me
especial.
too.
So we'd reject the null.
Yeah. Check. Yep. So
So their answer was P is close to 0. It's 1.15 with like 7 zeros to the left. What did they say? 1.15, and ours, I got 1.56. So
yeah.
it's different, but it's still really small. So I'm wondering if that P hat, if we should have tacked on the other 9, I don't know. Okay. So state your conclusions. So we reject the null. So that would say we would have insufficient evidence that students have been in a car accident. That over 60% of students have been in a car accident.
Yeah.
Reject. There is not sufficient evidence to claim that over 60% of students have been in a car accident. Yeah. Okay. You ready to do the test?
Yep. Yeah. Yeah.
Okay, I'm just opening mine. So do you want to figure out what we're doing today, or should we think about it and like email each other tonight, or text, or call, or?
Yeah, that's what I was thinking. Because I was thinking we could just kind of like read the link or whatever, just kind of think of something, and then just kind of text each other to see what we wanted to do.
Okay. Because do you want to deal with people or like observing and?
I think observing would be easier than like with people.
Unless you observed the people. So like, okay, and then would you want to do a quantitative or a categorical, like where it's either a yes or no, or something was more of them were, I don't know,
Yeah.
blue is more than red, or I don't know, or the number.
Mm-hmm.
Numbers we have to figure that out.
Yeah.
He did say that the categorical is easier.
Oh, okay.
But yeah, we'll just have to think.
Yeah. Yeah, but we could do that. Just kind of think about it and then text each other to see what.
Okay. All right, I'm open here.
Alrighty.
So the true symbol, the true population symbol is just P.
Yeah, just P. The P hat is the sample portion. Yeah. Okay.
Mm-hmm. So we've got information for these next 2 questions. The sample size is 100. The true proportion is 0.25, and the sample is 0.10. So it wants to know.
Yeah, if the requirements are met.
Yeah, so the first one is you do 0.10 times 100.
Mm-hmm.
And I can't think of it right off my head. I'm just going to do it. 0.10 times 100. So that is 10. Or you went 1 minus... Wait a minute, though. We are using the true population for that, right? The true population. That's what they have in the thing. It's just a plain old P.
Where do you,
I'm trying to find it in the reading
isn't
here.
it the P hat? I'm pretty sure it's the sample
Okay, look.
proportion.
Look at... Well, it's the 10th hat. But when you were doing that, you used the P hat and it was right. For the other one. See, that's why I'm so confused, because they say they're the same, yet there's two different numbers.
Yeah, because at
Okay,
the
when
end
it's
it says the requirements for a confidence interval are n times p hat and n times 1 minus p hat. The requirement for a hypothesis test involving one proportion are n times p.
So yeah, it says that there, but if you go to this other example at the end of the reading on page 10, it says the true requirements required to conduct a hypothesis test for one proportion are NP. It's just a regular P.
Mm-hmm.
I don't know. We'll just use what they like. Okay.
So what is it? Let's see. Oh, so it's a confidence interval. So then, if it's a confidence interval, we use p hat.
Okay. So what's the other one for?
It's for a hypothesis test.
Okay, I've got to write that down.
Yeah.
Because I was so confused. What is what? Okay. So we know that we use p hat. Okay. So the other one was 1 minus 0.10, which would be 0.90 times 100. So do both of them have to be met?
Yeah.
Okay. So they are.
True. The requirement for
Because the other answer.
conducting the hypothesis test, though. So it'd be
Okay, so
true.
this is where we use the P.
Yeah, just a normal P.
Okay, and that number is obviously higher, and the other one was lower. So, okay. All right. The study of the first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. So P hat for that. Wouldn't you go 45 divided by 60?
Yeah, because the sample is 60 people. Yeah. 45. 0.75.
Okay.
Create a 95% confidence interval for the true proportion of first-degree murder trials in the state. There, the verdict is guilty.
Do you know what? We haven't used our little Excel thing this whole time.
Oh, that's true.
I think we've made this harder than we should have.
Yeah.
So I'm going to plug that in. So X was the 45, right?
Mm-hmm.
N was 60. And okay, in this part where it says the null hypothesis, I'm
Yeah, I wasn't too
not sure what you
on-
put in.
Yeah, I wasn't too sure on that.
Well, it gives us the right p hat thing. Maybe it would just be 45 where it's the same. I don't know. Well, okay, that's what you're testing. Do we need the null hypothesis to get that? Let me put in something different. Okay. It's going to be the same because I put 0 for the null hypothesis and I put 40, like 0.45 for the null hypothesis, and the confidence intervals are still the same.
Okay.
So in that little tool here, I got 0.640 and 0.860.
Okay. And so
It should have
then,
been,
yeah. So then by hand you would have done,
to find the confidence intervals, put down the margin of error first, that thing, and then added it and subtracted it
to
your p hat.
to the 0.75.
Yeah.
Okay. All right.
See, and using the tool, it gave you the 0.75 already there for you.
Mm-hmm.
So.
Okay. All right.
Okay.
So if you increase the sample size from 60 to 80, what do you expect to happen with the width of the confidence interval?
Just be the same as the other deal, it would decrease.
Decrease,
Get
yeah.
smaller.
All right. To conduct a hypothesis test for what proportion two requirements must be met, suppose p equals 1/2. What is the smallest n? What is the smallest sample size can be, and both requirements still be met?
Okay, so this one we have to use a formula. So we're solving, let's see.
For n?
So in 3.1 of the reading, it tells you what to do. If you want to find the sample size required. So our margin of, so we're going to put in, okay, this n equals, and the z-score was 0.196.
Would you do that? Would you do that formula or the other one?
Well,
Oh wait, no, you would do the first one because it's giving you the p, which is 1/2. Half.
okay.
Yeah. So
So divided by, what was m?
Margin of error we have to find.
That's what we're finding?
No, but we have to find a margin of error because.
Oh. I wonder if does it show it in this other deal? I don't see it there, so I guess we'll have to figure it out.
So what information are we using?
Okay, let's write this down. Okay, P and P have N and Z and M. We have those things. So the P is what was P? Okay, P was $45. No. What is? Let's figure out what P is.
Yeah, that's why I don't. Are we using?
To find the margin of error, we have to know what P is.
Yeah. Do you want to skip those and do the other one and come back to them?
Sure.
Because both 9 and 10 are the same.
Okay. So for the water quality study in Reading, about 60% of the microvertebrate water quality indicators have been historically been associated with good health. So see, in that question, that would be that 60%.
Yeah. And that's why for 9 and 10, I don't know what information to use.
Wait a minute. It tells you what P is. We're retarded. P is 0.5 in number 9. Okay.
All
Do you want to go back?
Yeah, we can go back to it now.
Oh my gosh. Okay. Okay, so we're finding the margin of error. So it's going to be M equals 1.96 times the square root of 0.5 times 1 minus 0.5 divided by the sample, which was what?
What is the smallest?
What was the samples?
De las taxas no lo ocupamos ya.
Sí.
Now, what is the sample?
Mayor, que antes ponerte en un lado, pongo en otro y para muy tieso.
60. Random sample of 60 people.
60?
Te quedaron
Oh, okay, you're getting that from question 6?
Yeah.
Oh, okay.
Y luego se equivocaron.
So 1 minus 0.5 is going to be 0.5. 0.5 times 0.5 is, oops,
Okay, 0.25.
that divided by 60.
0.00416.
So you got to do the square root of that.
Mm-hmm.
So I got 0.0645497483
For
for the square root of that number. Times that by the 1.96.
I got 0.127.
That's what I got too.
Okay. All right, so that would be the smallest. Oh no, that's just
What
the
is the
margin.
smallest? Yeah, she's asking. Is that?
No, because that's just a margin of error.
Okay.
So now we got to do the
Now you
formula.
And deal. That would be n equals, you're going to take the 1.96 divided by the point. Crap, what was that answer? 127. I put 127, and then you square that and take 60.
Ese carpeta de qué es? Esa que está ahí en las escaleras, ¿no? Una carpeta de papel. No, es una color.
So I got 59, rounded 60.
Just a second. Oh, that
Yeah.
you gotta walk me through these steps. This is how I wrote my equation: was 1.96 divided by 1.7
Mm-hmm.
square,
Mm-hmm.
and then 60 times 1 minus 60.
Then 60. Wait,
Or is it 0.5?
it's 0.5.
Okay,
Yeah, because
I did the p hat. Okay. So what'd you get? Okay, point. So it was 0.25 times
0.25 times. I got
point
for
zero.
the
Did you get when you squared the z divided by
M
m? Did you get 238.17?
967635594.
Yeah.
Yeah.
Okay, so you times that by 0.25, and that's the answer.
Mm-hmm.
$59.545.
Yeah.
Okay,
So
sorry.
do we round that
Yes, you round it up.
to the
So-
whole number, right?
Yeah, so it'd be 60.
Yeah. Oh,
Oh boy, now to do it another one. Okay.
no.
So we're gonna go 0.10, right?
Yeah.
Minus. So I've got 0.09 divided by 60.
Yeah.
And then it should give you 0.0015 times 1.96. Should have 0.00294.
Where'd you get that for?
The margin of error, I times the 0.015 times that z-score. Am I right?
You're doing like 1.96. Your formula is it 1.96
Times the square root.
of
Yeah, I gotta find the margin of error first, and then
Yeah.
plug it.
Because I got like for my final answer I got 0.619.
For your margin of error answer.
Yeah.
Okay. So step by step, 1 minus 0.1 is 0.9.
Mm-hmm.
And then you go 0.9 times 0.1
Is
is
it 0.9 or 0.09? point
I have
zero
point because the let's see, it's 1 divided by 10 should be what point 10.
Mm,
1 divided by
I just put in the whole thing like 1.1 times 1 minus 0.1.
yeah.
And I
It
got
should be 0.9 because if you go 1 minus 0.1, which is that p they gave us, 1 divided by 10 is 0.1. 1 minus 0.1 is 0.9, and then you times it again by p. So you go 0.9 times 0.1 should be 0.09. Yeah, like I was giving you the first step.
oh,
The
okay.
first answer. Okay, yeah, I see what you're saying. So then 1 minus 0.09 or wait a minute. Yeah, I see what you're saying. Point one. Holy cow.
Right, I think I got
Times.
okay, square root. So for the 0.09 divided by 60, 0.0015.
Yeah.
Okay.
So I did it right, didn't I?
Yeah. Yeah.
Okay. So then,
And then,
yeah. So your final answer should be 0.00294 for the margin of error.
okay, just give me a second. Point. I got something different.
Did I skip a step? Did I not square it?
Let's see.
Okay, what am I doing?
Because I squared 0.0015 and I got 0.03872983335.
Okay, your answer is right. I skipped that step. So what is your answer?
I got 0.076. Or should, yeah.
But you don't round it.
You don't round it?
No, because you gotta go. Wait. Okay, what did you do?
So then,
Hang on. Then yeah, I don't think you round that the square root answer because you have to
oh
times
no,
that.
I was giving you the final answer.
Oh. Okay.
But for the square root, I got 0.03872983335.
Okay. Final answer is what?
Then the final one, I got 0.076.
Okay. So now I have to just plug that in.
Yeah.
So you gave me those answers for the M, and I'm getting different. I wrote them down, and then I was going back through them.
You're getting different?
Because
So 0.09 16.
Oh no, you're right. I did the wrong one. Sorry.
Oh, okay. No, you're good.
Double checking it, and I did
Yeah.
calculate the wrong points. Where we don't have more than one person here to check each other, you know.
Yeah.
You have to be there to do them. I just take your word for it. Make sure I'm doing it right. You're doing it right.
Yeah.
Okay.
I got the final answer. I don't know.
Okay. We're doing this. P is 0.10, right?
P. Yeah.
Okay.
The P is.
I'm almost done.
Okay, I'm just checking. Kind of rechecking it.
Okay, I got it's gonna round up to 60 again.
Yeah.
I got 59.858. Blah blah blah.
Yeah, so the 60 again.
Hello, present to it. It's Christmas.
So, are we good then?
Yep.
Alright, so for questions 11 through 16, use the following information. For the water quality study in the reading, about 60% of the microinvertebrate water quality indicators have historically been associated with good health. The researchers suspect the water quality in the area has decreased. They conduct a hypothesis test using significance level of 0.05 with the following hypotheses. The role is P is equal to 0.6. Alternative is P is less than 0.6. They collect new data, and this time N equals 80 and X equals 38 indicate good health. The conditions for conducting a hypothesis test are satisfied.
Okay, so the p hat value is 0.475. You should go 38 divided by n. So you have to have your p hat and times it by the sample size.
Or wait, you're saying for like the N times P hat and all that?
Yeah, but we have to figure out p hat. So it says, no, x, p hat is x divided by n, so it gives us that, 38 divided by 80.
Uh-huh.
That'll give us that number, which is 0.475, times, you gotta times that by n, and it has to be greater than 10.
So would we use that? Because for a hypothesis test, it's just P and not P hat.
This is, okay. Let me see. Oh yeah, okay. P hat is for the interval.
Yeah.
P is for, so we do 0.60. 0.60 times 80. P would be 0.60, right?
Yeah. Yeah, because that's the.
That's P.
Mm-hmm.
It's like the mean, the total proportion.
Yeah, the total, not just a sample.
Okay.
So,
So that number tested out good, and then if we go 1 minus 0.60, and that's,
and you're timesing it by 80, right?
for the first one, you do n times p.
Yeah.
And the next one, you go p times 1 minus p. Or wait a minute. I said it wrong. It's n times 1 minus p. You're right.
Mm-hmm.
Okay. They're both big.
All right. So just true. What is P? So now we would do 38 divided
That was
by
the point. 0.475 is what I got.
Yeah. Find the test statistic. So,
Oh, these are food.
just use the.
So X was 38, N was 80. The null is 0.60. We want to figure out if it's decreased. So I got a negative 2.282.
Just use.
I'm gonna make sure I got all that information in right.
So you go to negative 2.282.
Yeah.
Okay, yeah, I got that.
Okay.
Did it. So you just when it asks for the null in the little, like that kind of app thing, what do you put?
I put 0.60.
Oh, okay, yeah, because it just gives it to you.
Well,
Okay.
because yeah, they say the average is 60, and we want to know if it decreased.
Yeah, okay.
Yeah.
So, 14. What is the p-value for this test?
0.011.
0.011?
Yeah. Mom, you see the eyes. So it's low. So we reject the null. No. Yeah, we reject the null.
Yeah.
So there is sufficient evidence that the water in the area has decreased.
Yeah.
Yeah, I was watching a thing the other day of how to figure out exactly how to say that.
Mm-hmm.
If you ever reject the null, you always say that there's sufficient evidence, and then it's always what the alternative hypothesis is. Is the last part of your sentence.
Oh, okay.
So there is sufficient evidence to conclude, and then your alternative was that the water quality in the area has decreased.
Okay.
That made it a lot easier to figure out.
Yeah. I'm gonna have to write that down.
Okay, so let's go over them.
Yeah. So let's see. 3 is p. 4 is true. 5 is true. 6 is 0.75. 7 is 0.640 and 0.860. 8 is decreased. 9 is 60. 10 is 60. 11 is true. 12 is 4. 12 is 0.475. 13 is negative 2.282. 14 is 0.011. 15 is reject the null. And 16 is the first one.
Hang on. 13 was negative 2.82.
Mm-hmm.
My screen doesn't roll down as fast. 0.001, reject, and then okay.
Yeah. Oh, we got a B plus. The 260 ones were wrong. Yeah, I gotta figure out how to do that.
You figure out the margin of error. I mean, we were trying to figure out what P was, and we figured it out. It was in the answer.
Mm-hmm.
We've used our applet for that. No. I just wonder if we could plug in P there. Well,
We probably
depth
could.
and height.
Yeah, I'm gonna have to figure that out.
Hey, I think I might have to do office hours this week.
Oh,
There's a
okay.
few I missed on the test and just a few questions. If I don't get it figured out, then I'm gonna go downhill from here.
Yeah. All right.
So Okay, well, yeah, think about what you want to do because we got to get
Okay.
that turned in Saturday.
Okay, that's cool.
Okay, and if I'm kind of busy this evening, but let's for sure get it. Are you around Friday to get it figured out?
Yeah.
Let's
Yeah.
get it figured out Friday.
All right.
Sure. So you have
All
to
right.
fill out.
Okay.
Okay,
All right. See you later.
have a good week. Okay,
Okay.
bye.
Bye.
We'll talk to you later.
Yeah. Bye.
Bye.